Okay, so if you ever watched those movies or whatever where they kind of give you the ending first, and it's just like a really weird ending, and then what they do is they go through the movie, and by the end of the movie, you're like, oh, okay, now I see why that was happening. Okay, so today I'm going to give you the ending, or the moral of the story, or what I really need you to be aware of, and that is that, we'll write this at the very top, x plus a does not equal x plus a, actually I'll put this in brackets even, times x plus b over x plus b. Now mathematically you can say, oh yeah they do, look at that, and that equals x plus a. Okay, now is that the complete answer for this one? X cannot equal negative b. So if I can get you to realize that statement, then you will be successful on this objective. Okay? Basically, you can look at something like this really quick and go, oh, asymptote at negative b. But that's what they want you to pick on the test if you're not aware of what's going on. You have to factor the top. If something cancels, that's not an asymptote there, that is a point of discontinuity. Okay? Your calculator, not good at showing you these. But if you get an answer, I could show you exactly how to see if it's right. Okay? So here's another one of those that the calculator will not get you the answer, but it will certainly check it. Okay? Now, let's just look at this equation right here, because it's a good one to start off with. Okay? Now, again, I know right away we're going to look at that and go, oh, our vertical asymptote at 3, that's an asymptote. God, I'm so awesome. It's a good thing I studied. I'll question this quick B, and I'm on to the next one. Okay? And of course, that's what I want you to pick. And I don't want you to think, it depends how much you study, but on the diploma, if it's really easy, go back and see if they're trying to catch you on something. And I'm not trying to get you paranoid when you're doing it, but I have found often that if it's just really easy and it takes 5 seconds on a diploma, you should be like, okay, I don't think they'd be that nice, okay? So, I want you to factor it. Now, maybe we should even, let's get our calculators out. And let's put this in, okay? X squared minus 4x plus 3 over x minus 3. Okay, and then hit zoom 6 so we're all looking at the same thing. Now, does this show you where the point of discontinuity is? No, it doesn't. And then there's this thing where you could hit zoom decimal, and it does a really crappy job. It's probably the most useless button on this calculator. It is very hard to tell, but you know one thing is, this one isn't popping out asymptotes. So I should be thinking, hey, if it's not popping out an asymptote. Now, if you look really quick, you could probably think, oh, look, I bet you there must be a problem at 3. So you kind of have to know that to be able to check it. But then all you do is hit trace, 3, enter. Now, if you hit enter and there's no y value, there's a hole in the graph. Okay? So there isn't an asymptote at 3. There is a point of discontinuity at 3. But why? Show algebraically. They won't even tell you. There's a, show algebraically. So if you were to factor this one, this would be x minus 1, x minus 3 over x minus 3. And look, that makes sense now. So the answer to this is x minus 1, comma, x cannot equal 3. Okay? So it makes sense now. Okay, I get it. They cancel. And then I'm left with x minus 1. Now remember, x minus 1 is not the same thing as x minus 1, x cannot equal 3. See, if you ever see graph x minus 1, x cannot equal 3, why are they asking me to graph x minus 1? That's really easy. They might even ask you, what is the equation on the top? Or what is the equation in the numerator? From this alone, you could get the equation of the numerator. Because you'd have to take this and go, oh, okay, that means there was x minus 3 in the bottom. Must have been 1 on the top. Then I'd multiply these together, and then I would get this answer. Okay? Now, when you have something like this, okay, it will cause what we would say is a hole or discontinuity in your graph. Okay? Now, how do I find the coordinates of that hole? Okay, the calculator obviously doesn't give it to you. It says y nothing. So if you put your new equation, x minus 1, comma, x cannot equal 3. Now the irony to this one is, how do you find the y value? What number would I put in? 3. See, the irony of this is, if you look at the statement, you actually do the opposite to find. It says y equals x minus 1, x cannot equal 3. Okay? Have you guys ever, like, your parents said, don't go in that room? And you're like, why? And you have to open it up anyway, right? Okay? Well, this is one of those scenarios. Why can't I use 3? Okay? And if you plug it in, I get the answer too. I can use it. Yeah, you can use it in this, but you couldn't use it in the original. Okay? So 3, comma 2 will be my hole. So the number that's not allowed, use it to find the coordinates of the point that doesn't exist. Okay? So obviously that's how mathematics can be quite complicated when you think of that statement. Go find the point that doesn't exist. Okay? That's probably one of the dumbest statements if you think about it, but I did find the coordinates of a point that doesn't exist. Okay? And this is going through 1. So our graph is going to look like this. And 3, 2 is the point of discontinuity. Okay? So this is not a difficult concept. But if you're not thinking point of discontinuity, they will catch you on asymptotes. I know some of us will just factor the bottom. I don't need to factor the top. And of course, that's what they're wondering if you'll do. Okay, let's go to page 467. Okay, now, so for a point of discontinuity, it's just an open circle. So how do you go about all this? Well, first of all, factor the rational expression. So let's factor the numerator and the denominator, right? Now simplify by canceling common factors and substitute non-permissibles. Because if you don't substitute non-permissibles in there, then you have automatically changed the equation. It's not correct anymore. You're doing a different equation because x minus 1 is very different than x minus 1 where x cannot equal 3. Those are totally two different. You got to be thinking a rational expression when you see a non-permissible. Okay? Yep. Absolutely. Absolutely. And we're going to do one today. Okay? Now, this one here, okay, right away, asymptote at 1. Okay? Of course that's there for you. But maybe you should be going, okay, just wait a minute, I should check something first. Let's see if anything cancels. Okay? Now, what do you think the most common mistake students would do on this question? Come on, think like a diploma team that's making this baby. Why would they put this one on there? Yeah, you're going to think that's x squared minus 7x plus 6, right? Now, that's just mean, but you got to be on your game for this stuff, right? Now, how do I know? Let's just say I want to find out quick if it's an asymptote or a point of discontinuity at 1. You can do the remainder theorem. Now, does it make sense that if this top number divides by this, then there's an x minus 1 up here? Right? X minus 1 must be one of the factors of this thing, or else this wouldn't divide nice. Okay? Remember, 8 over 3, that's not a factor. Okay? A factor means it goes in nice, without a remainder. But if I have 8 over 2, well, that must mean there's a 2 up top. That's why they would cancel nice. Okay? So let's see if they cancel nice. In other words, let's see if x minus 1 can go into it. Now, there's two quick ways. One quick way is just put in the number 1. So if I put in, remember the remainder theorem, 1 cubed minus 7 times 1 plus 6. 1 minus 7 plus 6. So minus 6 plus 6 is 0. So x minus 1 is a factor of that. So therefore, I know that it's going to be a point of discontinuity. Okay? Now, depending how far you want to go through this, but if it says to do it algebraically, how would I go about this? Now, this was just a test, so I'm not wasting my time. Yeah, but let's do synthetic. And this is a good question. It really brings back all of the last unit, which I know we have such fond memories of. So if I was going to do synthetic, what number would be on the outside? 1. What numbers go inside? 1, 0, negative 7, 6. Okay, because the x squared term is not there. Bring down the 1s. 1 times 1 is 1. Okay, add them. It's 1. 1 times 1 is 1. Negative 6. Multiply it, I get 0. Okay? Again, I always work backwards, not counting the first one. So this is negative 6, 1x squared. Okay. Now, remember when I said whenever it's an x squared one, either use the quadratic formula or simple factoring. Now, this simply factors to what? X plus 3x minus 2. Okay? So that entire top equals, so we got, therefore, the top is x plus 3. Actually, I'm going to put the x minus 1 first because it's the first one we dealt with. X plus 3, x minus 2, all over x minus 1. Okay, this would cancel. So this is x plus 3 times x minus 2, comma, x cannot equal 1. Okay, now what is the point of discontinuity? What should I do to find it? Plug in 1. Okay, do what they said you're not allowed to, and I will find a point that doesn't exist. There's a lot of weird things in that statement, right? So you got to do them all. You do the things you're not allowed to go find something that doesn't exist. Okay, so if I put that in there, I will get 4 and negative 1, right? So if I put 1 in here, I get 4 times negative 1, so it equals negative 4. So my point is 1, negative 4. That is the point that doesn't exist. So we go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 3, 4, 5. Okay, so the point that doesn't exist is 1, negative 4, right there. Okay, what would be my x-intercepts? Or what are the zeros of this function? Let's do that. 2 and negative 3, right? Oops, I shouldn't put brackets around them, because it's not a coordinate. Okay, so 2 and negative 3, when x equals 2 and negative 3. So 2 is, I'll do it in red, negative 3 is there, okay? Now, if you look at this function up here, it is an even degree, right? X times x. You want to multiply the two out to get your degree. It's x times x is x squared. So this is an x squared graph. So it is either starting high, ending high, or starting low, ending low. Okay? Remember all those rules that you forgot? There's another weird statement. But anyway, what would this graph be doing? Would it be going opening up or opening down? Opening up. So I know I'm going to be doing something like this, right? Now, the other question I have is, how do I find the y-intercept? Set x to 0. So for the y-int, it would be 0 times 0 minus 2. So that is 0, negative 6. Okay, I got negative 4 there. So negative 6 is down here. So then I can sort of draw my graph, right? The amount of math to do this without a calculator is quite a bit. You got to know how to factor, you got to cancel, you got to find the point that doesn't exist, you got to put your roots down, you got to go find y-intercept, you got to know that it opens up, that it's an even degree, right? So lots of stuff is going on to be able to do this. Okay. Okay, so Kelsey kind of ruined the surprise. Sometimes there is more than one non-permissible that cancels. Okay? So sometimes there are 2 points that do not exist. Okay? If you thought it was ridiculous, we're looking for 1 point that doesn't exist. Now we're going to look for 2. Now, the top, just ugly right now. Let's not even go there. Because if I'm looking for points of discontinuity, why don't I factor the bottom, and then I'll use that to help me kind of chip away at the top, right? Because I'm looking. Obviously, if these go in there, I'm going to use them in my synthetic. Okay, now to do the bottom, I'm looking for 2 things that add to give me 7 and multiply to give me 10. This is so easy, it hurts. 2 and 5. I'm going to put 5 and 2. Oops, it's supposed to be a plus sign. Okay, so remember, and I still have students doing this, they're going x plus 5, x plus 2. Done. Done it wrong, but they're done, okay? This is one of these that has the number in the front, so we have to go through that extra step of doing the brackets. Okay, and I can take out a and x. So that's 2x plus 5. I can take out a 1. That's 2x plus 5. Okay, so the top, or the numerator, or sorry, denominator, 2x plus 5, x plus 1. Okay, that's the denominator. Now, if I want to chip away at the top, what is probably, you want to be good to yourself, right? Which number should I use? I would use 1. Why? Because I'm pretty good with 1s, right? I don't like to brag, put myself out there, but I am. Okay, so the other number I could be using, actually -1, is, what's another? -5/2. I'm not so happy with using -5/2. Okay, which is -2.5. Not the worst thing in the world, but it's no -1. Okay, so let's do it. -1. And then when you think you should just put it in quick. Okay, but you know what? Sometimes you got to use test wiseness and go, well, you know what? It's probably going to work out. I'm going to try it. Okay, and it doesn't take that much longer to do synthetic. So we've got a 2, 1, -16, -15. Bring down the 2. Okay, so then I go, and that's going to be -2, -1, -1, -15. That gives me 15 at 0. It works. Okay, so now I am at -15, -1x, and 2x squared. Okay, and remember, this is x plus 1. That's where I got that from. Okay, so now we can factor this, because this is all the numerator, right? That's what I'm doing here. So I'm looking to what two things add to give me -1, what two things multiply to give me -30. That's -6 and 5. That's 2x squared minus 6x plus 5x minus 15. Take out a 2x, that's leaving me with x minus 3. Take out a 5, that's leaving me with x minus 3. That is x minus 3 times 2x plus 5. Okay. So now I am done. That is x plus 1. This is the numerator, right? Times x minus 3 times 2x plus 5 all over 2x plus 5 and x plus 1. Now this, after doing this amount of work, I probably feel pretty comfortable on the diploma because look how nice it worked out. It was a bit of work. Okay, it wasn't just looking at it and going, oh, these are the asymptotes. Okay, now there's these two cross out, these two cross out. So my answer is y equals x minus 3. Sort of. I need to put a comma. X cannot equal -1 and -5 over 2. Okay, which is aka -2.5. Therefore, what are my points that don't exist? How do I find them? Plug in what it said not to. You're not allowed to use these. I'm going to anyway. Okay, so -1 minus 3 is -4. So -1, -4 is one whole, and then y equals equals negative 2.5 minus 3, that is negative 5.5. So the other one is negative 5 over 2 and negative 11 over 2. Okay, so it says determine the points of discontinuity. I just did that there. Make a rough sketch. Okay, now I have x minus 3. That's a pretty easy sketch. Okay, first of all, b is the minus 3. B stands for the y-intercept. So I got negative 3 would be down here, right? And it is a simple graph with a slope of 1. Now that is the graph of x minus 1, or x minus 3. But mine's x minus 3, x to not equal negative 1, x to not equal negative 5 over 2. So if negative 1 is right here, and negative 5 over 2 is right here, okay, then this would be a hole here of negative 1, negative 4, and this one here, which would be negative 2 point, or I'll use the fractions, negative 5 over 2, negative 11 over 2. Okay, so there's a really good question for really covering most of last unit and everything up to this unit. Okay, so we'll look at 1 to 3, 5 to 11. Okay, and be careful with domain and ranges. Most of these ask domain and range, domain and range, domain and range, because the diploma does.